This is the solution to exercise 6a. In this exercise, we're going to extend the FizzBuzz application we developed in exercises 5, and we're going to add a NoSQL database as a cache. So when somebody requests a range, we'll first check to see if the result is in the database. If it is, we'll return the result from the database. If not, we'll calculate the result, store the result in the database, and then return the result to the user. So to do this, we're going to launch into Bluemix, and we have our FizzBuzz application from exercise 5. And what we're going to do is we're going to add a service. So we click to add a service, and then in the search bar we can enter Cloudant. And we click to add the Cloudant database. We can leave the values as default and then just select create. When you add a new service to an application, you'll be asked to restage the application. This is so the service can be bound into the application. So now the application is back up and running and we have a Cloudant database. Before we write the code, we do need to do a few things within the Cloudant database to set it up for the application. So we click into the Cloudant service and then we launch into the console. I could do all the actions I'm about to do in code, but to keep it simple, we're going to do it manually. So the first thing we're going to do is add a new database, and we're going to call the database FizzBuzz. If you'd use a different name, you need to be aware that we use this name in the code later on, so you'd have to make sure they match. My recommendation is, at this stage, just use the name FizzBuzz. So that's created our database, and then the next thing we want to do is we want to add a design document. This is going to allow us to search for a particular document within the database. So we say we want a new design document and we're going to create a new view. As this is the first time we're creating a design document, we have to give it a name. So I'm just going to call it FB for FizzBuzz, and the index is going to be called range. Again, these values are going to be used in the code, so need to ensure that you use these values. And then we're going to just change the emit function here, and we're going to say doc.from doc2, and we need to put this as an array. So that's how the map function should now look. We're going to admit an array with doc.from and doc2, and once you've done that, just select save and build index. And that's us finished within the Cloudant console, so we can close that down now. So next we go back into Eclipse, and we're going to pick up from the code we created in the previous exercise. So as I shut down my Eclipse between the exercise, I need to go and open a new terminal. If you're picked up from the previous exercise, you may have the terminal still running. It's important that you make sure you're in the correct directory. And if you have Mocha still running, you'll need to Control-C to quit out of Mocha. So now we're in the correct directory. We can install the Cloudant library. So it's npm install Cloudant. Now I want a specific version of the library, so I can specify that, and I say save, and again save exact, which will ensure that I have exactly the version that I want. So there we are, we've got Cloudant version 1.0.0. And that's updated it in the package.json. F5 to bring that change in. For the sake of speed, we're not going to use test-driven development here. I'm just going to develop the database code, and then there's an optional section at the end of this exercise to go and look at how you test an external service. So to implement this, I'm going to need a new file. So right click, new file, and we're going to call this cache fizzbuzz. And I'm bringing the code in from the example. So here we're going to bring in our previous implementation of the fizzbuzz API. I'm going to create a new cache fizzbuzz object and give it properties of a database URL. We're going to bring in the Cloudant library and then create a new fizzbuzz object. And I'm going to make that object available to people that require this object. And just to set up the test, we will go and create the test file as well. So, new file. So the next thing we want to do is we want to get access to a Cloudant database. So I'm going to do this in the server.js file. And if you remember from the charts, we need to look at the environment variables before we can access any service. So we're going to import the new cache file here, and then after we've looked at the server host and port, we now want to parse out the environment variable for the Cloudant database. So under the code to get my host and port, I'm going to put this code. So we're going to look at the vcap services environment variable. That's going to return me a JSON document. Again, if I come back into Bluemix and look at environment variables, this is the JSON document that would be in vcap services. So you see we've got the Cloudant, and then under credentials we've got password, username, port, host, and a URL which we can use to connect to Cloudant. So I use that URL and I add to the end of it the name of the database, which I called fizzbuzz. So that's now going to allow me to log on to the database. If I'm not running on Bluemix, so if I'm running a local test, I still need a parsable URL. So I've provided a local version so I can run tests within Eclipse and not fail on the URL parsing. And then while we're in the server.js document, the last thing we need to look at is the endpoint. So normally we'd update this code to look at the cache and use the cache version of FizzBuzz. But what I'm going to do is I'm going to add a separate route so we can test independently both the cache version and the non-cache version. So after this route, just here, I'm going to add in the new code. And what we're going to do here is we create a new endpoint called cache FizzBuzz range. And then I call my cache FizzBuzz. Now, because this is asynchronous, because once we get into database calls, we end up using asynchronous calls. Rather than just being able to send the result here, I need to create a callback function. And that callback function simply sends the result back to the requester. I could use JavaScript promises, but to keep it simple again, I've just used the callback mechanism here. So once this finishes, it's going to call this function, this callback function, which will simply return the results back to the end user. This is a standard pattern in JavaScript when handling asynchronous calls. So we finished all the work now in the server file, so I can save that. So back in my FizzBuzz, we're going to add a number of functions. So the first one we're going to add is the call that the server makes. So we're going to ask for a FizzBuzz range, we're going to give the start and the end, and we're going to use a callback. So similarly, we extract the parameters and we create a key. So this is the key we're going to use to query the database. And then we're going to ask the database, which we use the view function. We're going to give it our design document and our index. We pass in the key. And once the database call has finished, it will call back this function. So again, this is asynchronous. And I need to provide the function to handle that, which is what we're going to do next. So this method simply creates the keys and then asks the database, do you have this record? So then the function to implement that callback, I'll just make this a little bit bigger, is here. So the first thing we check is the error code. And as long as we don't have an error, we look to see, do we have any rows from the database? If we do, we remove some metadata that the database adds in. And then we look at the document. There should only be one row in this cache, so we get the first record returned. And that should be the result that we want to send back to the user. If there is no error and there is no data, then we actually go and create the data. And we do that just as we did in the previous example. We create a new JSON object and we add the data in. If there's no error we'll then go and store that. But if we got an error back from the database, we'll just return this to the user. We won't store it. And then we call back the callback that was handed to us. So this is the callback from the original requester in the server.js file. And that will then send the data either from the database or what we created back to the end user. So the last function we need to go and implement is the function to store calculated results. And this is a very, very simple function. We just ask the database to store the data. We do an insert. Again, there's no error checking in this. I'm trying to keep it simple for the purposes of this exercise. So that is now the functionality complete. So this should now work and give us a cached version of FizzBuzz. What I'm now going to do is move into the optional section, and we're going to show you how we'd test the database. So when you create a unit test, the important thing is that we don't want to go outside the module that we're testing. So when I make calls into the database, I don't want to actually go out to the database. I don't want there to be any network traffic, so I don't want to contact the database in any way. So in the previous exercise, we used a spy to check the functionality of a call, and there are two additional features that we can use to actually block the call. So instead of just spying on it, we can block the call and replace it with some code that we add for the test. And we call these a mock or a stub. So a stub will just stub out the call, and it allows me to provide a return value. So if the call had been made live, I can sort of simulate the return. And a mock does a similar thing, but then allows me to look at the behavior of the call. So I can actually do some more detailed analysis of how the call was used. So if we look at the code that we've just written, you'll see there are two places that we talk to the database. One is when we're inserting data, and the second is when we're actually searching for a record or a document in the database. When we call the stored calculate results, all we need to do is check that the call has been made. So we've actually made this call and we've passed in the correct data. That's our side of the contract or the API. Okay, so we're now going to go into the Cache FizzBuzz test, and we can implement the test for that Cloudant insert. So to do that, we actually need to create some test data. So this is a test result that we should get back from the calculate FizzBuzz. And then that is the data that would typically pass to the insert. So if I look at the test that I've just written here, we create a new object, and again we have to pass in a valid URL. It's not going to be used, but the library will parse that out. And then when we look at the DB store calculate result, or calculate result, all we want to do is we're going to use a mock to mock the Cloudant object, and then we say mock expect when the insert function to be called with the arguments provided, and it expects me to call this only once. So this is the argument. So then I go and call calculate DB store calculated results, and again I pass in a JSON document, and then I just verify that the expectation created in the mock was actually satisfied. And again, at the end of the test, I make sure that I restore the function to its original. So this is a very simple test. I'm just checking that when I call dbStore calculate result, I actually go out to the database and pass the right data as a parameter to that call. So that was quite simple. The next function that we need to test is where we go and look at the database. So there are 3 tests that we need to cover. The first one is when I find the document in the database. The second one is when there are no documents in the database. And the third one is if the database returns an error code. So similarly, to do this, we need some test data. So I can bring this in from the exercise. So I've got a test result from 1 to 20. I've got a test result from 2 to 21. And then this is actually what the database will return. And you can get this using the Cloudant console. So the Cloudant database can be queried directly using its REST API. So I just queried the range, the index, the view that we created using the key 1 to 20. And this is the document I got back from the database. So it shows me the total rows in the database, the offset, and then it gives me an array of rows. So this is the result that I parse out. It'll always put within the document an ID and a revision. So this is the data that I strip out if I get a successful row. And then this is the result as it's stored in the database. So we just insert the tests here. And let's go through the tests that we've created. So we're going to test the process database results, and we're going to use a SPY. Now, there's 2 features that we've not used before, which are very handy. So within a describe, I can put a hook for before all the tests, after all the tests, or before each test and after each test. And this just reduces the amount of code I have to write, because before each test, I actually want to go and spy on a particular function. And after the test, I need to restore that function. Again, I don't want to go and test the functionality of the code we created in exercise 5 because we've already got the tests that cover that. So I just want to make sure I'm calling that function correctly. So let's get on to the first scenario. We're going to test when Cloudant returns a valid result. So the first thing I need to do is I want to spy on the dbStore calculator result. So this test is going to test the process DB results. And the first thing we need to do is we need to create the callback function. If you remember in the server.js file, we needed to pass that callback function that will return the results back to the sender. So whenever we call our cached FizzBuzz range, we need to pass in that callback. So this SPY CB function spy is going to act in place of that callback. And then the next thing to look at are these two hooks. Within a describe, I can set up one of four hooks. I can set up a function to be called before all the tests, or to be called after all the tests, or the two that I've used here is this hook, this function to be called before each test is executed, and similarly after a test is finished, I call this function. These are just handy hooks that I can use to save having to set up this code around each of the tests. So before each test, I'm going to spy on the convert range to FizzBuzz. So this is the code we implemented in exercise 5 just to calculate the range, the FizzBuzz values for a range. Again, I don't want to test the functionality of this code because we did that already in tests created during exercise 5. I just need to make sure that I'm calling this module correctly. So this spy will allow me to do that. And then after the test, I need to make sure I restore that. Similarly, because we're going to do some tests on the callback function, I need to make sure that I reset that spy after each test. So now let's go back down to and look at the individual tests. So the first test is when the database has the valid results. So initially I set up a spy to look at the store calculated result function. And then I call process results. So this would be the callback function after I look at the database. So when I do the Cloudant view, this is the callback function that gets passed in there. The false is if there was an error returned. DB results are the results returned from the database. Then I've got the data passed in, the start, the end, and then the callback function. My expectations, I expect the callback function to be called once with the test results. I expect my function to calculate the results never to be called, and I expect never to call the store results to the database. So that's how I test to see whether I've got a valid set of data back. If there's no results in the database, but there was no database error, again, I create this. This time it's a stub because I want to prevent the database actually being called. So I call my process DB results callback function. No error. I'm going to use DB results set 2 and the range is from 2 to 21, and this is my callback function. So here I expect the callback function to be called with the result set 2, and I expect that to be called once. I expect to have to call my calculate FizzBuzz function, and I expect it to be asked for a range from 2 to 21, and again that should only be called once. And then I would expect to call the store calculated results to be called once, again passing in that newly calculated result set. And then I just reset the stub here. And then if there is a database error, I expect that we're going to call the callback function once, because I still want the function to be called. I expect to have to calculate the results. But this time, because there was a database error, I don't want to call the store results. So they are the 3 tests that we created. And I've just realized that I missed one of the result sets out here, so let me just add that in before I run this. This is the database result when there are no rows returned, so there's no value found. So then again, if I run node modules bin mocha -w, you see that we do now pass all of the tests. So my cache fizz buzz, all those tests work correctly. And then what I can do is, just to finish this off, I can push this and you can see that pushing that caused the build to be initiated. And there we go, we've now deployed our new code. So again, I'm just going to copy this, launch this in the Chrome browser, and then the URL is cache fizzbuzz range, and we'll do 1 to 20, and we get the value back as expected. But if this time we go back and look at Cloudant and we look at all the documents, you'll see we've got 2 documents. This is our design document, and if we look in here, you'll see that we have our range from 1 to 20, and then the results are there. So requesting that range added our entry into the database, and then when we request it again, this time we'll be getting it from the database. And that's the end of exercise 6A.